Hey, Breakthrough Junior, Kiras here. So, this is a neuron. This monster is responsible for all the headaches and pain you suffer. In this video, I'm going to talk about how we feel stuff and how does painkillers work. Now let's take a closer look to the neuron. We call these branches dendrites. They are responsible for receiving an impulse. The transmission of a nerve impulse along the neuron from one end to the other occurs as electrical changes across the membrane of the neuron. The axon is responsible for the electrical transmission of an impulse to the axon terminal. And here we have the axon. Before the impulse, the neuron is polarized. That means the inside of the cell is negative with respect to the outside. And that is because sodium potassium ATPase pumps pump potassium ions inside of the cell while at the same time pumping sodium ions outside the cell. When an impulse comes, voltage-sensitive ion channels open and sodium ions diffuse into the cell. This action depolarizes the cell, making the inside positive with respect to the outside. Once the cell is loaded with sodium ion channels close and potassium ions start diffusing out of the cell, repolarizing it. That means the inside becomes negative again. And after repolarization, sodium-potassium ATPase pump starts working again, making the cell polarized. This is actually very similar to maglev trains. An alternating current occurring on the tip of the train creates a magnetic field, making the train move forward very fast. After the train moves, the rail it goes by returns to a non-magnetic field, just like the cell repolarizes, getting ready for another impulse. Now, the impulse is at the axon terminal. It's time for chemical transmission. When the impulse reaches to the axon terminal, these voltage-sensitive calcium channels open, letting the calcium ions diffuse into the cell. And since they are secondary messengers, calcium ions stimulate these synaptic vesicles. Then, the neurotransmitters inside these synaptic vesicles get out of the cell to the synaptic cleft by exocytosis. Then, neurotransmitters attach to the receptors on the other dendrite, opening ion channels and letting sodium ions diffuse into the cell, making it depolarized, successfully passing on the impulse. Now this goes on and on until the impulse reaches to a motor neuron, causing us to feel. Now let's get to the painkillers. Painkillers work by attaching to the enzymes that create prostaglandin, the chemical responsible for the production of pain. Painkillers simply restrain the cell to excrete neurotransmitters, making it unable to pass the impulse. But Kiraz, doesn't painkillers make the pain go away? No. They just make you not feel it. Okay, now let's be real. We all have headaches. And we all use painkillers sometimes, but taking too much painkillers is actually bad for your nervous system and your body. So the next time you have a headache, just try to drink some water and get some rest if you don't feel too much pain. Because nervous system is not only responsible for the pain you suffer from, but also all the joyous feelings. Like petting our tiny friend. Or like walking barefoot on grass. Don't damage your nervous system by overtaking painkillers. Thank you for listening. Stay safe.